find the speakers, what you do when you get up here. First, you cue Dave, and when he says start, you start, and then you introduce yourself.
Well, Migo, I was going to wait for the rest of the people to get fortified.
Well, that's a good idea.
No? Okay, all right. My name is John Harbold. I'm helping Ting out with producing C Macros for the Arduino EForth. And because I have over 30 years experience programming in C, because I get paid to do it, I know it sounds like I'm selling myself out, but you know, some places where I've worked, you mention the word fourth and they burn you at the stake. Okay. Like I said, we're going to be presenting the Ansi C Macros that can be used to create the fourth dictionary running EForth on the Arduino. The Arduino system uses the GCC, the GNU compiler collection, to build whatever. Okay, and the thing, as Ting outlined before, his EForth is written in C. Okay, but his dictionary is created by Forth, rightly so. But you know, if you look at things like GForth will create their dictionary in C. They call them primitives. Okay, the C language has a facility called macros. It's part of the preprocessor. And using this facility, we can create a word, the various fields for a word, namely the link, the name, code, and parameter fields of a fourth word. And these are the outline of what the basic fields are. The link is used for searching for a word in a dictionary. The name field is used to identify the particular word. It's a counted string where you have a byte. The first byte is the number of succeeding characters in the fourth word. And then you have a code field which is used to execute the following parameter field words. Okay. This one it basically explains how the link field works. The first word in the dictionary, the link field, is null, and in Ting's implementation, succeeding links point to the name field. Am I right there, Ting? Right. Okay. And here the name field again identifies the fourth word. It's a counted string. First byte is the length. The rest of the bytes are the name. Now, I may be off on this, but for the Arduino architecture, a 16-bit word has to be aligned on an even boundary. Okay, that's another thing that I added to these macros. So that if you have a name field which is odd, it gets padded with an ASCII null. The code field, again, this points to C code, which will execute the following parameter fields. And again, this code field has to be on a 16-bit boundary. And then the parameter field can be the CFAs of previously defined words, or they can be primitives. All right. I have basically two C field macros. The link field, which what it does is it writes the pointer to the previously defined word, and an end word which updates this link pointer. I have a name field which you just pass the name to it, and it just writes the counted string and we'll pad it if necessary. I have something called fourth word, which it does both. It writes the link field and the name field. And then further, I created something called a colon word, which does what a fourth word does, and it writes the do list primitive in the code field. And then the code field is just basically this. You just put the name of the C function that will execute your C code. And then these are the parameter fields. You can have, again, a parm field, which is just the name of a previously defined fourth word. You can have a primitive, which, you know, if you guys have, some of you have in the previous talks from Ting, he's actually listed out what these primitive, they're basically numbers. And what I did was I gave those numbers names. And then there's a word field if you have to plunk in just a 16-bit value. And then comes the interesting thing. Fourth has immediate words, which means they are executed right then and there. These do the equivalent of those words. We have the begin until, and what they do is they make a finite loop for your words. Then there's the begin again, which is the infinite loop. Then there's the if then and the if then else. Okay. We also have the begin while repeat and for next. This is something Ting has invented. Okay. And also, I've noticed in his code, he has something called aft then. And that makes what this does is this is equivalent in C of something called a do loop, which means it's basically the word do. You have a compound statement of words you want to execute, and then down at the bottom you have the condition which keeps the loop going. Okay, this is what the dictionary looks like. I'll explain. I'll have an example of what the dictionary.h file is. I have a code word. I call it flash dictionary. And what we have here is you can see the link field for the first word here is null. And you will notice that the way you can do the initialization is you can either initialize as a 16-bit or a short, or you can initialize as a character. And one of the nice things about the C is I added comments. Those are the things between the slash, star, star, slash. You can see that here the LFA equals null. The NFA is called TMP, and that's the address that it's at. And you can see the counted string. You have 3 and then TMP. Then following that is you have the CFA, which is 6. And in this case, it's a primary. It's a primitive, and it just shows these primitive numbers, which offhand I forgot what they do. And you can see here, then it ends with. Like I said, I just copied this thing out. Okay, now we go to a more complex word, wrote. You can see here the LFA is at address 230, but it points to 21E, which is the previous name field. It's the pointer to the name field of the previous word. You can see the NFA is at address 0232. It is a 3-character word, ROT. The code field address again is at 0236, and it's 60, which I assume is like a do list, I believe. And then you can see the code field addresses. We have 0238. That points to more R. That's 2R. Then the following one shows is swap. And then R more is R from. And then we have swap, and then I do an exit. And that ends the word. Okay. Dictionary.h. In C, there are things, different types of data structures. There are structs and there are unions. A struct is like a collection of different types of, things like characters, shorts, unsigned logs, even other structures. A union is different. That what it says is I can either, in this case, I can declare a code word to be either a character or a short, and that's 16 bits. Then whenever you create a fourth word, what I had to do was I had to create another macro. In this case, temp, TMP, CFA is the address of where the CFA is. Is that right? Yeah, for this given word. The same thing with rotate. And if you want, I have the complete stuff on here. I just wanted to get something going. So, any questions?
Does this actually allow you to have all of this statically laid out?
Yes, exactly. If you look at the way Ting's output is, it's a list of 16-bit values. Okay, they're numbers. Very hard to if you have a problem, it's very hard to debug. What I have here is I added comments, which will tell you, at least you can go in the code and see where everything is. Okay, and yes, go ahead.
So is it actually manually statically laid out?
Yes, yes.
Insert a byte?
If you have to insert a byte, well, this is a fourth word. This is going to be going into Flash. Is that right? Okay, this is going to go into Flash, so basically that's really not going to change.
Well, no.
No, this is the, I'm sorry, this is the basic fourth dictionary.
So you wanted to change your definition of rock for some reason.
Okay, now, no. One of the things we wanted to do with this EForth is to be able to create new fourth words through the interpreter.
Manually entering all the hex addresses?
No, this is going to be put into Flash. We want to be able to have what's called a split dictionary.
No, you're not answering.
Oh, well.
You were showing a bunch of what looked like manually entered hex addresses.
Yes.
Are they manually entered?
No. C will create those for you. It'll be a file which will get compiled in a sketch, and then that dictionary will get loaded into Flash. What we want to do is we want to be able to have a split dictionary so that we have, one dictionary in Flash and then another dictionary in RAM where you can go in and start creating fourth words at your will. And then if you like all these words, then what we'll do is we'll have another set of words which we'll be able to transfer those into and append them to the dictionary that's in Flash. Yes? Right? No, this is really just being able to get the initial fourth dictionary into Flash and be able to do it in a manner that's easily debugged. Okay, the way Ting did it was he actually uses the fourth metacompiler to generate this array. And again, I have examples of what that looks like. And it is I found it to be kind of hard to follow. But you brought in, huh? And that's, well, I had to, Ting, I had to. So,
This isn't the source that goes into the metacompiler, this is the output.
the output will be an array. Okay, yes.
Let me see if I understand questions related to the other questions they asked me. So when you actually create a colon word, for instance, and does that generate code that the C compiler uses to generate the macros to generate stuff that's loaded by the C compiler, or you talking about
It generates what it,
manually coded or whatever? This is automatically generated stuff that the C compiler can use. Is that correct?
yes, what it does is it generates an array which Ting's fourth engine will be able to interpret.
Yeah, but in terms of when you compile an image for your dictionary, for instance,
Right.
what is the C compiler using to do that? Is it a file that's automatically generated when a person enters the colon?
No, no, no. This is way before. This is actually building EForth.
I think the answer
Yes, it's
is more set.
yeah. These are the core words. That's right. I'm sorry. These are the core words that will be used to build EForth. Okay. Yeah. And Ting's currently, from what I understand, Ting's currently working on being able to enter colon words at the prompt. Right. And when I get time, I've been keying in my own, keying in his core words into as C macros. And I said, and afterwards, if you want, you can come by and look at what I've done. Next, the December meeting, I'll show you in exacting detail what I did. Okay? Okay. All right. Well, any other questions? So I'm not thoroughly boring. Thanks, guys. Okay.